Welcome to Perspectives from HSBC. Thanks for joining us. And now, on to today's show.
Welcome to this edition of HSBC's Perspectives. I'm Stuart Riley, Group CIO of HSBC, and today I'm delighted to be joined by Arvind Krishna, CEO of IBM. Arvind, welcome.
Stuart, it's great to be here with you.
Nice to see you. Look, I guess you're right in the heart of everything that's going on at the moment, and what a fantastic time to be in technology. I don't know about you, but I find it just a pleasure to work in this industry at the moment, so it's super exciting. I'll start, if you don't mind, by using the old adage that in technology, people often overestimate in the short term and underestimate the long term. I feel like AI is going to make that adage truer than ever. I mean, how are you seeing that play out?
Look, absolutely. To your point, people always overestimate what it could do in 2 or 3 years. A lot of that is to do with adoption and all of the inhibitors which we know are there in most enterprises and governments. And they dramatically underestimate the 10-year point, sometimes maybe the 5 or 6 year point.
Yeah.
You know, I think internet is the classic example. I'm old enough to remember in 1995, people were predicting 10, maybe 100 million total adopters over the next decade. Instead, we were in the billions.
Yeah.
But when they thought about what it could do in the first 2 or 3 years, not quite there.
Yeah, massively overestimated.
Yes.
Yeah, and so obviously, I mean, AI now, I guess most people think of generative AI really starting probably with the launch of OpenAI ChatGPT in Q4 2023. So we're sort of 2 years into that journey. Yeah. Where do you see that we are today and the next steps?
Yeah, so I'll use a baseball analogy. I know a lot of your audience doesn't follow baseball. Just think of it as a 9 innings game. Cricket is 2 innings, so It's a 9 innings game. I kind of say AI is in the first innings. So you don't quite know how the game is going to play out, but you're on the field, it's going, the players are out there, you know who's there, but you don't know who's hot, who's going to win, really.
Yeah.
By analogy, cloud is probably in the 5th or 6th inning, so it gives you some sense that's mature, you kind of know what's going to happen.
Yeah.
So that's where you are. But you got to be on the field, you got to be playing, you got to be worrying about which use cases will scale. And I think from a big, long arc of technology, think of AI like the internet. By the way, there's only 8 big technologies. It's not that many. If you begin with the steam engine and think railways, go forward all the way to semiconductors, which enable computers, internet, AI. So it's kind of in that big arc of importance.
Yeah. And I've heard you say on numerous occasions, giving advice to CEOs and boards, suggesting don't experiment with hundreds or thousands of things. Focus on the things that can scale. Can you give me examples of that?
Sure. Look, so what happens is it's new, it's exciting, you read a lot about it, and before you know it, 100, 200 experiments blossom all over the enterprise.
Yeah.
Now, to make AI really give value to the enterprise, you got to worry about your data. You got to worry about putting some guardrails. You're going to have some ethics around it. You're going to integrate it inside an application. All of that takes investment and takes expertise. Is it tens? Is it hundreds of people? Well, 100 times 100, I don't think you're going to spend 10,000 people on an experiment. So the reality is 90% of them are going to fail.
Yeah.
That leaves a really bad taste. I kind of say it's mature enough. Understand which ones could scale and impact it at enterprise scale. Put all your investment behind those 3 to 5. You'll learn. Now you'll get better at it. And by the way, 2 or 3 years down the road, you might have 100 going, but start with 3 to 5.
Yeah. Get some wins on the board.
Wins on the board and scale. Scale is really important.
Yeah. What sort of examples are you seeing people focus on at scale?
I think there is 4 use cases in buckets. Lowest risk, easiest one is customer service.
Mm-hmm.
No question about it. Like even in a bank, I'm sure there are people who call in to say change an address, or there are people who call in and say, look, I forgot something around my account. Or they call in and say, I forgot just my online credentials. Yeah. I think at least half, if not all of that, could be handled with AI.
Yeah.
Those are, I call them low risk, because you're not making a credit decision or something.
Yeah.
If you think it's a higher risk, that 10, 20%, it's not more than that.
Yeah.
In your call center or in any online experience, punt that to a human.
Yeah.
But all lower, number one. Number two, I would say your enterprise operations, especially around the back office, invoicing, payments, what I call it, HSBC paying its vendors, like even people doing maintenance in a building. You do have that. All of those things I think could be automated at least half away with AI. And in your main function, I think elements of automation, which I know you are a big fan of, Stuart, whether it's run books, it's code books, it's problem triage, programming. I think you could easily get to see 20-30% productivity improvement, which allows you to handle all that tech debt a lot better. And the fourth one, which is unique to a bank, I think, is around risk. Worrying about how do you onboard a customer, all of the paperwork that you have to do. Why can't you take half that burden away? I think are the four buckets.
You mentioned risk at the beginning of that in the context of whether deploying a Gen AI model was risky in a context or not. How do you think about assessing that risk? Like, how do you think about whether something is risky with a Gen AI model?
Look, I kind of think of Gen AI as we're trying to mimic how a human being operates. I don't know about you, but in my experience, humans are not always great at having perfect recollection. They think they have it perfect, but when you go back to a record, they're often only about 80% accurate. But they have complete conviction that they said that or they behaved like that maybe 6 months or a year ago. Why would we expect Gen AI to be different? Okay, so if that's the case, now you have to go back and say, look, if it's customer service and if it's giving an answer, verify the answer. The moment you have got a verifier built in, you're taking that, what is called hallucination, or I call being incorrect, you're taking it down from 20% down to less than 1. At that point, you're probably better than your human agent. It's not going to be a perfect like 100, but it's going to be 99% accurate.
So setting the benchmark as how does a human respond or behave in this situation, and can we better that?
Can be better than that. And actually think of it this way. Using Gen AI maybe in conjunction with a human, are you making your newest, most inexperienced professional up to the level of an experience? That's quite a win by itself.
And of course, you free up people to do other things that are more
valuable. More complicated things, and in the end, facing up to your customers is what you want people to be doing.
Spending valuable time with them rather than administrative or bureaucratic tasks, etc. And you mentioned coding assistants. I'm a huge fan of Gen AI for coding. Actually, I've used many of the models to do my own coding in my spare time to play with these models. How much efficiency are you seeing in IBM for your engineers?
I'll give you 3 numbers. I know people get fascinated by the 30, 50, 90% that some people talk about. I'm going to shock you. But this is across a base of 25,000 engineers. We are seeing 6% today.
So pretty low by some of the numbers that get quoted.
But I like 6 because I think that that's an honest and real number as opposed to
the inflated.
I actually believe that 6 will climb to 25 to 30 over the next 1 to 2 years. So not that long. Now that people are getting used to it, and it gets to 25 to 30 by taking on a lot more languages, a lot more tasks, not just coding. So my 6% comes from just actually a very simple 1 and 2 line completion.
Sure.
But I can get now to more procedures. I can get to full documentation. I can get to test case generation. So I can see it climbing to about 30% quite well. Then I did an interesting experiment inside IBM. I asked people, what about patching? Because that's different than writing code. And suddenly they found amazingly that with a little bit of work, it was really, really good at doing patching. Because that's a very, very unique and specialized task, as you know. And one that a lot of people don't exactly love.
It's not fun.
It's not fun. But it's essential. And there suddenly, I think there it could be 50 or 60% actually.
So it's choosing the right task.
It's choosing the right task. And if you think about application maintenance, which is patching, it's half the bank probably.
A significant part of our expense, for sure, But today it's still, it's certainly very expensive to train a large model. Obviously, DeepSeek changed that picture a little bit, but it's still a pretty expensive capital outlay to train a large model. Inference costs are coming down, but actually, if you're doing it at scale, it's still significant GPU costs, etc. What do you think happens to the cost profile in the next few years?
I'm going to give you a prediction that will sound counterintuitive and surprising. I think in 5 years, the total cost will be 1% of today's cost.
Wow.
So 100 times cheaper.
Wow.
And I know a lot of people say, well, that's semiconductors. No, semiconductors normally gives you about 2x every 2 years. So that's maybe 5x over 5 years,
Yeah.
not 100x.
Yeah.
But the semiconductors, competitiveness in the semiconductor market, because when you only have a few suppliers, prices tend to be high.
Sure.
I think more will come. Then I think there will be a lot of algorithmic advantage. And the piece that very few people like to talk about, instead of using a 100 or a 500 billion parameter model, these are massive by the way, by any scale in technology.
Yeah.
I think you'll find that for 99% of what you want to do, a 3, 7, 10 billion parameter model is actually better
Yeah.
and with less hallucination than a big model.
Yeah.
That says you got to be able to use those smaller models.
So small model, defined or
For a
distilled
domain.
down for a domain, specialized, locally deployed.
Locally deployed, and locally deployed means right there you get another 2x. So let's add it up. Semiconductors gives you 5x, algorithmic gives you another 5x, small model gives you a 5. 5 times 5 times 5 is 125.
Yeah. Okay. And actually, again, you sort of raise an interesting topic, because I thought the DeepSeek moment was genius in many ways. What they achieved is amazing, but I thought it also reflected the fact that these things hadn't been optimized. There had been no need to that point to optimize, and so it really demonstrated to me that the optimization journey is only just beginning.
I'm going to poke a little bit of fun of my own industry, the tech industry. If you think that you can draw a big moat by convincing everybody, look, it's really, really expensive, don't bother to chase us,
Yeah.
there's no motivation to go optimize. If, on the other hand, as tech has shown again and again, people might start that way, it's not like some other industries. Then the barrier falls, because once one proves it, then everybody runs after
Everyone's running.
That's why that was my middle 5, the
Yeah.
optimization piece.
Yeah. And again, you touched on models getting smaller, and therefore cheaper to train and run, etc. Where do you see the balance between training versus inference, and the shift potentially?
The value for those who deploy, and that in the end is the only value that matters, is all in inferencing.
Mm-hmm.
So if over time inferencing is not 10 or 100 times larger than training, we got a problem.
Yeah.
This is an implosion going to happen. So that's clear. But that may take 5 or 10 years to get to that point.
Yeah.
So that's part one. The second point, I actually believe very strongly that on the large versus small, we are going to need a few large models.
Mm-hmm.
Think of them as teacher models, or the ones you use when you have no idea what you might exactly be wanting.
Yeah.
There's space for a half dozen, maybe a dozen, but that order.
Yeah.
It makes sense. They can get their return on tens of billions of investment.
Yeah.
And then there will be hundreds and thousands of much smaller models built using millions, not billions.
Yeah.
And I would predict actually that on the small models, HSBC could well have maybe a dozen of the smaller models
Yeah.
that you use that are unique to you.
Yeah.
And that unlocks your enterprise data to be used in that context.
Yeah. Do you think quantum comes into all of this?
Look, quantum is the first time we have actually a new computing architecture in 70 or 80 years. That's why it's so exciting. Even AI, it's really, really exciting, but it's built on digital deterministic bits. It's not actually that different. A funny way to say it is AI and computing is great. It looks at the past, it looks at data, and then it can do things that are remarkable. But they don't do the future. Quantum is going to help us design the future. So when we look at areas like materials, like risk, like optimization, quantum is going to give us techniques which we can't even dream of into those worlds. And so the things in risk which we thought were just too expensive to compute can be done.
Yeah.
And this is going to be here upon us quicker than we think. Like, I would predict by the end of this decade. Not next.
I've heard you say that before, and I'm going to play devil's advocate a little on this. I feel like I've been in this business for sort of 30 years now. I feel like quantum's always been 5 years out. What makes you think that this 5 year out is
No, I don't think
closer?
it's 5. I think in 2015 we would have said it's 10 to 20. Don't know exactly,
Okay.
but it's 10 to 20.
Yeah.
To me, this is engineering. So I'll just put some numbers on the table.
Okay.
You need a machine that is big enough, because if it's small, who cares? You can simulate it or something. So big enough. 2, it can't have too many errors, and quantum inherently will have errors. But
Sure.
you got to get the error rate down to where it's very, very much more usable.
Yeah.
And three, quantum, because it's using tiny amounts of energy, tends to dissipate or become noise very quickly. So how long can the machine remain coherent? So that's three. There are not 5, 10, 20 things, those three.
Yeah, fix those three and
Fix
you're
those
in
three
business.
and you're in business. So on the scale point, 10 years ago, people were talking about 4, 6, 8 qubits in scale. Okay, who cares? That's a toy. Today, we are in the hundreds. We actually have 75 quantum computers on the cloud, not simulators, actual quantum computers,
Yeah.
13 of which are in the hundreds of qubits. Okay? I need to get hundreds into thousands, so a 10 times advantage.
Yeah.
Error rates right now are sitting around 10 to the minus 3. Need to get them to 10 to the minus 2. At that point, error correction works. At 10 to the minus 3, 10 to the minus 2 is hard, 10 to the minus 3 we can get there.
Yeah.
And coherence time needs to improve by about another 10 times. We think these are actually 3 to 4 year problems.
So I was going to say, because when you look back over the last 5, 10 years, the advancement that's been made is then roughly equivalent to the advancement that needs to be made once again to get there. Is that?
No.
No?
I think we needed to do a 10,000 times advancement if I take it over the last 15 years.
Yeah.
1,000 of which has been done. The last 10 is to be done.
Okay.
So
there's
that's
why still a
my
step
confidence and conviction. So we've done a lot more. These have been improving about 3 times each year.
Yeah, yeah. So actually, and jumping slightly, but still in the theme of quantum, given your prediction, we really ought to be very much today working on cyber techniques that are kind of quantum proof, which are readily available today. So we know we have that technology, but I think we need to be deploying those more rapidly, given the prediction that you're making. Is that your assumption?
100%, Stuart. So you might have a lot of data that you think is protected today. But when quantum comes along, it may be able to read that quite quickly.
Yeah.
So it's not that it's going to sort of come backwards in time to today, but if you have something encrypted and you think it's safe because it's encrypted,
Yeah.
that could get read, and that's a problem.
What haven't I asked you about AI that I should have asked you? Is there anything?
Look, I'll just mention one thing always. I think the scale point we mentioned and talked about briefly is really, really important. Pick a few that can scale, because the learning inside the enterprise of then how to do it is really, really important.
Yeah.
And really focus on deployment much more than the invention side.
Yeah. And I guess in the world, everyone's using this term agentic today. I find agentic, it's a useful term in a way, but I mean, what it really means is that the AI model is calling other APIs to enact something. Do you see that as a significant development or just a natural development of where we were heading?
To me, it's natural. Because I'll use the word, whether we use the word process management or we use the word workflow.
Yeah.
In the end, no application was ever a single program. It was always a workflow that went across multiple systems.
Yeah.
And the reason we decompose it, because as good engineers, you've learned a long time ago, decompose each task into something that is not too small but not too big.
Yeah.
Because then it's fixable.
Manageable.
And now you can put it all together to do something that is a lot more remarkable.
Yeah.
That's what agentic is. So it's not a surprise. To me, it's a natural development.
Yeah.
But we should also be careful, because agentic can also go awry and bring up costs pretty high.
Yeah.
So we should also be careful at where we begin to apply it. But if you put it in a constrained box, I want you to worry about getting a mortgage application approved. Don't make every decision, but can you do some of those pieces using agentic? That seems a natural use case.
So you're breaking down specific processes and looking at which part of that process makes sense.
Correct.
Yeah. And I guess this highlights the importance of an API strategy. So for the audience that are not familiar with API, we're talking about application programming interfaces, so effectively how one piece of software talks to another. But if you're a company that doesn't have a great API strategy, doesn't have great APIs, it's going to be pretty hard to take advantage of this type of technology, isn't it?
I think you're going to end up at a competitive disadvantage to those who already have that strategy in place.
Yeah.
And can begin to use it to be able to deploy AI and agents both.
Yeah. I mean, this is where I see a significant advantage for HSBC, because we've got the breadth of services and products that already exist. We've got APIs, and so we've now got this ability to digitize those businesses fairly rapidly. Well, look, thank you so much for joining us today. It's been a real pleasure to speak to you. As I say, the engagement with IBM has been fantastic, so we look forward to continuing to partner with you.
Stuart, it's always great to talk to you. Thanks.
Great. Arvind, good to see you. Thank you.
Thank you for joining us for this episode of Perspectives. Make sure you're subscribed to HSBC Global Viewpoint to stay connected